Hello, everybody. I'm going to go through a Chemthink, and this will be the Chemthink for that will be due next week. Okay, so I'm going to present. There we go. And I think I'm going to turn off my face. There we go. Oh, select share. Okay. Okay, now, one of the things that is a problem with Chrome is it doesn't do a good job with Chemthink, because Chemthink uses a type of presentation software called Adobe Flash. So when you watch the Chemthinks, you really need to use Internet Explorer or Firefox. So how do we do that? How do we use a different browser? Well, I'm going to go to my Start button, and I'm going to type in Internet Explorer, and you can see that it comes up. I click on it, and there it is. There is the Internet Explorer. So I'm going to put that on one side of my screen. Okay, and then I'll put the presentation on the other side so that you can see the I want to make sure that you can see the closed captions, because I am not sure when you watch this, you will not have the ability to see closed captions. Okay, so on one side of the screen, you see the Google Meet. And on the other side of the screen, you can see the Internet Explorer homepage. I think that this will work. Okay, so what I'm going to do is I'm going to type in Chemthink. Chemthink, there it is. Okay, I'm going to pick the first one here. All right, it's working. I'll put in a fake student that I created. Okay, now notice that it goes to this screen first when you get into Chemthink. It says, welcome to Chemthink Covalent Bonding. We don't want the covalent bonding tutorial. For some reason, it opens up on this page. So a lot of students, they're just going ahead and they're doing the covalent bonding. Well, that is not assigned yet. So I'm going to go back to the main menu. And here we have the screen that you should always start with. This tells you under activity, it tells you the activity that you're supposed to do. Then it has a due on date. And this will tell when it is due, whether you did it or not, and upcoming assignments. Completed tutorials, it tells you how many times you tried you did the tutorial. It also tells you how many times you attempted the questions. And if you finish both the tutorial and the question set, it'll say check mark done under do on. Now you can see that I did not do the atomic structure. However, you can still do I could still do the atomic structure. I just click on this arrow here. And there it is, atomic structure. So those of you who did not do that, I suggest you do that to prepare yourself for the final. Okay, I'm going to go over the ionic bonding tutorial today. So I click on the arrow, go to the tutorial. In this tutorial, we'll look at how ions are formed, the forces that hold the ions together, and how the structure of the ionic compound relates to its formula. Notice that the progress up here, it says 1 of 27. That means you have 27 slides. Okay. This box contains 2 negatively charged particles. And notice there's a negative sign to indicate that it's negative. It also has shading in the circle. It has shading to make it look three-dimensional. Okay, so think of these particles as spheres that have a charge. So I'm going to click on one and try to drag it to the other one. And notice how they repel each other. That's the idea. Now let's look how ions with the opposite charges. So what do you think is going to happen? One has a plus, one has a negative. They attract each other. And that's just the way magnetic forces work. If you have 2 magnets, if you put it in one position, they attract. If you put them in a different position relative to each other, they repel. Like repels like, and opposites attract. Okay, the oppositely charged ions attract each other. When they are close enough, they even stick together. Opposite charges attract and stick together. Alike charges repel each other. In order to build an ionic compound that sticks together, you need 2 opposite charges, both positive and negative charges. The positive ion is formed from an ion that has a tendency to lose electrons. Since metals can easily lose electrons, the positive ion will usually be a metal. And we recognize this. If you look at the yellow portion, on the right-hand side, there's this stair step. So this is the periodic table. Draw the stair step. Anything on the left of the stair step is a metal, and it tends to lose electrons. Atoms on the left of the periodic table tend to form positive ions. Why positive? Because they lose electrons. If you lose a negative charge, if you lose negativity, you become positive. On the other hand, elements on the right hand of the stair step tend to gain electrons. Since nonmetals form ions by gaining electrons, the negative ion will usually be a nonmetal. And notice also here that there's one column on the far right that is in its own category. Those are the noble gases, of course, and they don't gain or lose electrons. So far, we have learned the following. So let's sum this up. Metals form positive ions because they lose electrons. Nonmetals form negative ions because they gain electrons. Therefore, metals and nonmetals can bond together by forming what we call an ionic bond. How does it happen? Well, the positives attracts the negatives. Let's take a closer look. Okay. Choose the sodium ion as the metal and the chlorine as the non-metal. Let's choose those two. Now, notice how the chlorine atoms have a strong attraction for electrons. Under certain circumstances, the chlorine atom will be able to take one electron from the sodium atom. And again, notice how we model these with circles, or if you look at the shading, it looks like spheres. An electron is ripped from the sodium atom, and be aware also that the sodium atom actually has 11 electrons. These electrons are at different layers. And so the electron that the chlorine takes from the sodium is on the outer layer. The chlorine atom gains the electron and becomes negatively charged. And where does this electron go? Not to the inside, it goes to the outer layer. There it goes. Also, notice how the ion, when they become an ion, they change their size, their physical size is affected when the electron is transferred. Since the two ions now have an opposite charge, they attract each other. The ions are held together by the attraction between the opposite charges, and this is called an ionic bond. Now, please note, the process you saw was a simplification. Let's take a look at this again in a way that more closely resembles the way we see these atoms would interact in the real world. So, one thing to notice here is that when we talk about actual substances, for example, on the left we have chlorine gas. Notice how the gas particles, the chlorine is a molecule that has two chlorine atoms in the particle, in the molecule particle, and it's floating around like a gas. Now, sodium at room temperature is actually a solid, and each sodium atom is arranged in a metallic crystal. The actual sodium atoms are in a regular structure next to each other, just like you're in a classroom and you're in rows and columns in the classroom. We think of the chlorine gas as a particle that has two chlorines. We think of the sodium metal, the sodium solid, as individual sodium atoms just sitting in a regular structure. Each chlorine atom in the C2 molecule, the C, the little 2 on the right of this capital C, lowercase l, that means there's two atoms of chlorine, needs one sodium atom to react with it. So each one wants one, so it's going to interact with two sodium atoms because each sodium atom can give away one electron. They attract, and look what happens. The end result is that each sodium is bonded to one chloride. Notice how I say chloride instead of chlorine. When a nonmetal becomes an ion, you add the little IDE at the end. Remember to watch that opposite charges attract. Watch what happens next. The positive ions will attract any negative ions around them, just as the negative ions will attract any positive ions nearby. So this sodium up here is still positive, and this chlorine on the other particle, the other sodium chloride, is negative. So what's going to happen? Look what happens. They arrange themselves so that the sodium is touching, the sodium on the top here is touching two chlorides, and the sodium on the bottom is touching the opposite sides of the chlorides. The chloride is touching two sodiums, and the other chloride is also touching two sodiums. So they automatically arrange themselves so that the charges, the opposite charges touch each other? What if we have a whole bunch of these sodium chloride pairs? What's going to happen? What do you think is going to happen? Let's find out. Notice how because of the magnetic forces, right? Force is something that causes something to move. Because of the attractive and the repulsive forces, they automatically arrange themselves in a way that minimizes the attractive force. How do you do that? Well, you put the positives against as many negatives as possible, and you put the negatives against as many positives as possible. This continues into 3 dimensions. Drag the crystal below to see how this might look. So there we have 3 dimensions. And again, notice how if you have a red particle, and I can't remember what that was, the sodium. If you have the sodium, the positive sodium, notice how it's in between the negative chlorides. If you have a negative chloride, which is the blue spheres, they're in between positive sodium. Right? Again, so the whole idea is that the positives try to get as close as possible to the negatives, and the negatives try to get as close as possible to the positives. At the same time, however, notice that the negative chlorides are repelling another negative chloride. So what's the optimal arrangement? Well, in this case, the optimal arrangement is what you see. Notice how the simulation allows you to even flip it. Okay, in the 3D molecule, each ion is surrounded by oppositely charged ions. There are no distinct molecules. Instead of calling this compound a molecule, it'd probably be better to call it an ionic crystal. Now let's take a look at how we might write this formula. Okay, take another look at the crystal. Tap each ion below to count the number. Okay, I'll start with the sodium, which is the red. There's 1, 2, 3. The chloride is the blue. 1, 2, 3. Do you notice anything? There's a 1 sodium for every chloride. Since the crystal contains a 1-to-1 ratio, we write NaCl. Right, so this is the lowest ratio. You take the total and you reduce that to the lowest common ratio. In this case, for every sodium, there's 1 chloride. And we write as a formula NaCl. Now these letters, they come from the periodic table. Sodium is Na, chloride is Cl. And note, this formula, it accounts for the ratio. It doesn't account for each individual particular atom in the piece of sodium chloride that you might have. There are no molecules in this ionic crystal. What that means is there's no molecules in the sense that you have 2 atoms that are actually attached to each other physically. They're actually sharing electrons. And we will get to a more deeper understanding of what molecules are in chapter 6, the next Chemthink. In ionic compounds, the formula tells us the ratio of the ions, not the total number. In a molecule, you are told the total number. In the formula, it tells you the total number of atoms in the particular molecular particle. Okay, so let's try this again. Rotate the crystal, then count the number of ions in the crystal. Okay, the calcium is the gray. So 1, 2, let me see, 1, 2, 3, 4. It looks to me like there's 4. 1, 2, 3, 4, calcium. So I'm going to click on this plus here. 1, 2, 3, 4. The fluoride looks like there's 4 on the bottom, and if I flip it, there's 4 on the top, so that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 4 calcium and 8 fluoride. So what's the lowest common ratio of 4 and 8? What is 8 divided by 4? 8 divided by 4 is 2. So you can take this 8 and 4 and you can reduce it to 2 and 1, because 8 divided by 4 is 2 and 4 divided by 4 is 1. So we're looking at a formula that has 1 calcium and 2 fluorides. There it is. The calcium to fluoride ratio is 4 to 8. Since this reduces to a ratio of 1 to 2, we write the formula as CaF2, calcium fluoride. Okay, in this tutorial, you learned the following: how ions are formed, why ions stick together, how to write an ionic formula. Okay, so we just finished the tutorial, and now you would go on to the questions. Now, okay, guys, I am going to stop the video here, and then we'll continue with the questions in the next video. Bye-bye.